Hello everyone, welcome to Mean Life Studies. In the previous video we have seen how to order the data by using order by class or sort function, and also we have seen group by class with different aggregate functions, right? So now in this video we are going to discuss a very important concept, that is window functions. In every data engineer interviews you will be getting at least one problem from this concept. Okay, so now we are going to see how we can implement each and every window function with help of PySpark scripting. So before that, if you understand implementation of these functions with help of SQL, then you can easily understand PySpark script also. Okay, for that I'll be starting with SQL. I'll be explaining all window function with help of SQL first, so that you can understand PySpark easily. Okay, let's see here. So what is the data frame that we are using? Data underscore df, right? So data underscore df. So this is the data frame we have. So now we can also write SQL queries on top of this data frame, right? So how we can do that? If you observe, there are different language support also there, like Python also there, SQL, Scala, R, right? So now we are going to write SQL queries on top of this data frame. How we can do that? So now we are going to store this data underscore df dot. You can see here there is the option create or replace with temp table, right? So create or replace temp table is there, right? So here this is the temporary view that we are going to refer. So with what name that you are trying to refer, I'm just using in bracket employees. Okay, now we are creating a temporary view. This is just like a temporary table in our SQL, right? So now I'm going to write SQL queries on top of this data frame, right? Now you can see select star from, you can see by default when I'm writing select star, you'll be getting this recommendation, right? So magic symbol. Now so select star from employees. So now if I execute this one, you can see here you'll be getting a table. So this is exact table, this one only, right? So this is the data frame, this is the SQL table, right? So now I'll be starting with all window functions. So how we can implement the window function? So what is the difference between aggregate function and window function here? So in aggregate function, you will be getting a single value as output. When it is taking a multiple values as input, it is returning only single value. But in case of window function, you will be getting the same value for all records. For example, if you are trying to find the total salaries for the entire organization, what you are finding? Total salary. So how we can do that? Select sum of salary from employees, right? So you will be getting a value. You can see here, this is the total salary for the all employees, but you are missing remaining all data, right? So you are not getting employee IDs, name, age, and remaining all you are not getting. Even though there is a possibility that you will be getting a more data, like if you are finding location wise total salary or department wise total salary, you can also find it, right? So let's do that also. Select department wise sum of salary from employees group by of department. You can see here, if I execute this one, you will be getting a few more records related to their each and every department wise total salary. You can also find it for each location wise also, right? Now we'll see each location wise. Select location and sum of salary from employees. So now if I execute this one, you'll be getting how many locations are they, those respective. You can see what is their error. So the query did not, okay, we have to use group by, right? So group by of location. So now you can see here, we'll be getting 3 only records because each department might be located in a particular location. Okay, so now we are getting location wise total salary, but here also we are losing all data, remaining data. So what is the possibility? Let's see here. So now our requirement is to return all data. With addition to that, we'll be getting total, right? So for that, what we have to do, we have to return all data. With addition to that, we are going to find total salary. Sorry, we are going to find the total salary, right? So from employees, right? So what we have to do, we have to group by of each and every column because we are returning all, right? So we have to use ID, name, age, salary, department, and then location. So even if you're missing any group by, you will be getting error, right? Now you can see we will be getting so same data, right? So this is the exact data, but if you observe, what is the salary? This is not the total salary. This person only salary, right? Because we have used group by of all this combination. So how many groups it will form? How many records are there? Those many it's going to form. So that is where, in order to get these responses, like I need to return total entire organization total salaries, or department wise or location wise these salaries. At the same time, I should not lose our own data. I mean our original data, right? So how we can do that? That's where we are going to use this window function. Okay, let's see here. Select star comma sum of salary and just adding over class. So you are just adding over class to this particular aggregate function. Then this will start working as window function. Okay. So what is the window here? In over class we have another two classes. That is, one class is order by, another class is partition by. So if you are defining nothing in this over class, that means by default this will come under single window. So how many records are there? Those many will come under single window. So that for all records, this value will be replicated. Okay, let's see here. So now from employees table. Okay, now if I execute this one, you can see here. So we are getting all data. So this is all our data, but with addition to that, we are getting here, you can see here. And this is 14,30,000. So this is the total employee salaries in this organization. Now you can see what is this value here. We already find it, right? You can see here. So this is the total value. And if we are returning that also here, but we are not losing any data, you can see here. We are getting all data, but with addition to that, we are getting this data, right? So even if you want to mention this column name, you can see here as total salary. Okay. So if I execute this one, you can see here. You can see here. So we are getting all data. With addition to that, we are getting these total salaries. So how many people are there here? 6 employees are there, right? So now you can see here, 6 employees only there, right? In data frame, how many employees are there? 6 only, right? For 6 employees, the total salary is 14,30,000. And if you are using alone, you are losing remaining data. But if you are using window function, then we are getting our required data, that is total salaries. With addition to that, we are getting all remaining data. Right. So you might be asking, if you want to find the department wise, we can also find it. So you already observed, right? So if you want to find department wise or location wise, you can get these responses, but you are losing remaining data also, right? So let's see here. I'm going to find, to do that, what we have to do. Let's see here. Select star comma sum of salary. I already told you in over class we have two classes. One is partition by and another one is order by, right? So now I'm just using only order by of ID. Okay, so by default this is a ascending order, right? Order by ID ascending order from employees. So how it's going to return? It's going to return the total salaries in the order of this one. This is nothing but rolling values or cumulative values. You are finding rolling totals, rolling total salaries of each employee. Now you can see here in the order of order by IDs, right? So the people are going to join one by one in this order. You are finding the total salaries. You can see here. Here I'm just writing a column name for this one. So here I'm just using rolling totals. You can see now 45,000. You can see 45,000. Next one 50,000. Okay, so 5 lakh. This one, okay, sorry, this is 4 lakh 50,000. Na? So this is 55,000. So first one is 4 lakh 50,000. But the next one, if you observe, it is the addition of these two. And the next one, it's addition of these three. So finally, at the end, you will be getting 40 lakh 3,000. I mean 30,000, right? You can see here. So this is how you implementing running totals with the help of window function. You are just adding over class only order by. So that you are returning these details in the order of this one. Not only this order, you can also mention here descending order. So that you will be getting in reverse order of, I mean you will be getting say here. So in the reverse order, right? So in the reverse order, now you can see 89,000, 89,000. So 76, the addition of these two you can see here. The addition of these three you can see here. So likewise this total value, right? So this is running totals with the help of SQL, right? I hope you understood. So we have seen two cases, like without any class and with this class, right? So let's see here. So what will happen if you see here? Okay, I'm just copying this one. So we discussed two cases. So now this is the first case, right? So if you are not mentioning anything, so that you will be getting totals for each and every record, that is 14 lakhs, and that is right first case, and before that is second case. Now I'm just using only partition by. Partition by what? If you want to find only one column, you can use one column, or if you want to find two columns like department wise, location wise, you can also mention two columns also. Now for now I'm just finding department wise total salaries. You can see here. So what you are getting, so we already seen department wise total salaries, right? So where is that? Here you can see data analytics 11 lakhs 20,000, software 1 lakh 44,000, data science 1 lakh 66,000. So remember these values. Now we will be getting those values here, but without losing any data. So we are getting all data as we want. And now if you observe, you are getting right. So 1 lakh 12, okay, 11 lakh 20,000 for the data analytics team, and then 1 lakh 66,000 for data science team. You can see here, and these are average, sorry, not average, total salaries for each department, right? So similarly, you can also find it for location wise also. You can see here, probably you will be getting the same because each and every data analytics team lies in a same location. You can see here, same values, right? So this is third case. Now we'll be seeing next final case, that is, so how many windows has formed here? So windows means how many partition by location, how many locations are there, those many windows it's going to create. So for the entire total records, it will be divided into these many windows. So how many? 3 locations like Bangalore, Chennai and Pune. So for 3 departments, like 3 windows will form. For each window, this value will be allocated, right? So let's see here now. So we are going to add 2 classes like partition by of department, and in the order of ID, I'm going to mention only ascending order. Now, if you observe here, you will be dividing total 6 records into how many windows? How many departments are there? 3 departments. So you are dividing those 6 records into 3 windows, and for each window you are finding in running totals. You can see here data analytics team. So this is the first salary, and the next one you are adding off the previous sum of these two. So in each window you are finding the running totals. This is fourth use case. Okay, so we are just implementing only sum, right? So with the help of sum, you are seeing, right? Similarly, you can implement with any aggregate function, not only sum. It could be average, it could be minimum, it could be maximum for these 4 cases. Okay, so let's see how we can implement these use cases with the help of PySpark. Okay, let's see that now. Now, so what is the data frame we have? Data underscore df, right? You can see here. So this is the data we have. Now what we have to do? So in interviews will be asking to implement running totals. It could be average or it could be totals. Okay. So first we'll see here. What you are doing here? You are adding the overclass. So it is how, this is how you are defining the window, right? So in order to define the window, or in order to make this working as window function, you have to keep overclass. First you have to define the over, and then you are going to mentioning this and all. Okay. Let's see here. Now in PySpark, in order to apply the window function, you have to import it from function. Okay, let's see here. From PySpark dot SQL dot window is there. You can see here, right? So window is there. You have to import window function. You can see here. Okay, first you have to import the window. So like here, first we are going to define the order, and then we are going to use that order in our overclass. Okay, not only order, you can also implement any partition by also. Okay, so let's see here. I'm going to defining it order. Okay, I'm just using order by ID. Okay, how we can do that? So we already imported window, right? So window dot order by of, I'm just using column, right? That is ID. So you have to use like this, and then we are going to implement one more, right? So we are trying to implement running totals first, or you can also implement anything. So we have seen different use cases, right? Let's see here. I'm just using now data underscore df dot with column of, I'm just writing, okay, I'll define this first and then we'll write it. Okay, so now data underscore df dot with the column of, I'm just trying to find the total salaries. Okay, total salaries for the entire organization. So now you can see here how we can do that. So what is this one? Sum of salary, right? So then here what you have to do, you have to use overclass. In this overclass you are defining nothing. For example, if you are not defining anything, you will be getting that like total salary will be written for all. I'm not even using that order by class. You can see here. So over missing one required positional argument window, right? So because of, so what we have to do? So we have to define, right, window. So how we can define that? Okay, let's see here. So here, even if you are not defining anything, you have to mention like order by of something like this. Okay, let's see here. I'm just defining like this. Now in overclass, I have to define order by ID. That means you're not defining any order, and also you have not defined any partition, so that you will be getting that value, or like 14,30,000 is right. So that value you will be getting as a result as another column. You can see here. This is first use case we have seen, right? So what you're doing, you are finding the total salary like using sum of salary. With that, you are adding overclass. In that overclass, you are not defining anything. So here also you can define it, right? you can see here window dot, I'm just not defining anything. You can see here. You can see here. So how it's returning, window should be a window specified. So like how I specified. Okay, so that is the reason you have to mention whatever you define it, no problem. Even if you are not defining any partition by or order by also, you can define like this. Okay, so now you can see you'll be getting that one. So this is first use case, right? So then next use case, what is that? We have used only order by, right? So let's see here, order by ID 1. I'm just defining it here. So window dot order by of ID. So by default, this is a ascending order, right? So now you can see I'm defining now window order. So now data underscore df dot with the column of. So now what I have to do? So this is a running totals, right? Running totals, comma, sum of salary, and for that we have to use over. In that over we have to define the order by this one, right? So that you are finding total salaries in the order of this one. Okay, so now if I look at this data, you will be getting running totals as another column. You can see here. So 45,000, I mean 45,000 or 45, okay, 4,50,000. Next one, 5 lakh, this value 5,000. Next one you can see here, and the final value this one only, right? So interviewers will be asking this one more frequently, running totals. Okay, so first we are writing, we are returning one more column. So what is that? Sum of salary, and what you are doing, adding over class. In over class we are defining this one. That is the second case. Then final use case, third use case, win order by, okay, not order by, partition by department. Okay, like this I'm just using. Now you have to define window dot partition by of, what is that? Department, right? Like this. Okay, you're defining it. Then so data underscore df dot with column. Okay, I have to execute this one. Okay, execute it. So now data underscore df dot with column of. So what is this one? We are finding department wise total salary. Okay, so now we are going to use sum of salary dot, in over we are going to add this one. That's how we define, right? Each window. You can also define here also, no problem. So you can also define window dot partition by of department. You can also write directly, but if you are writing directly you'll be missing some brackets and all. So that's why I mentioned before. You can see here. So now if you observe, we are getting exact values, right? So this is for each department wise total salaries, right? So you can also find it for each location also. You can also change this one. You can see here you're getting, and also you can also remove this entire, and this is what we have defined it right here. So you can also mention partition by of department. You can also directly mention it. You can see here you will be getting the same result. Okay, what is this error? So there might be bracket is missing. Okay, you can see here there is a bracket missing, right? You have to close this bracket. Now you can see here you're getting same result, right? So this is for the total salaries for each department, right? This is the third case. In final use case, that is each department wise running totals also we can find it, right? So then now I'm just directly writing here. So data with column of department wise running totals. Okay, see here what you have to do, sum of salary dot over. In this over what I have to do, so I have to define window dot partition by of department, and then what I have to do, order by of ID, right? So this is how I define two classes. Now if I look at this one, you can see here you will be getting each department wise running totals. You can see here 4,50,000 this value, and this is normally returning, and then next value is returning as addition of these two. You can see here, so 90,000 you are getting 90,000, but the next one the addition of these two, right? In software also you can see here you will be getting normal, and the next one you are getting addition of those two, right? So this is how you are going to implementing all window functions. It could be sum, it could be, you are making this aggregate function will start working as window function, not only sum. You can also find it for the same thing. You can see here I'm just writing here itself now. Okay, here if you are confusing, okay, if you are confusing, I'm just writing one again. So data underscore df dot with the column of, so first I'm writing here, okay, first one what I have to return, I have to return first one total salary, okay, and then what is this one, sum of salary, right? For this one I'm just adding over class. In this over class we have to mention window dot order by something. Okay, so what is this error here? So why it is not returning recommending over in over? I'm just using window dot order by. Okay, let's see what is the error. Okay, it's showing. Okay, so let's see here. I mean, it is not recommending, but it's taking only. You can see here, you're getting right. So this is for total salary for the entire organization. You can also find it for each. Let's see here. This is one column, right? So now we are going to find dot. Okay, I'm just using in another line. Now we are going to use with the column of. I'm trying to return one more. Okay. So here, not here. You can write after, right? So you can write here. Not show, here you are going to write it. This bracket is for this one, and then we are going to write after that with column of. Now what's that? I'm just using average salary. Okay, with this salary, what I have to do? Average of salary. With this you have to use over. In this you have to mention window dot order by nothing. Okay, now you can see if I execute this one, you're getting averages, and this is the total, like total average for all employees. You're getting it right, right or wrong? So even if you want to like cast also, you can do casting and all. Okay, I already explained that before, right? So this is how you are implementing. So then we'll see one more, like slash dot with column of. I'm just using total employees, EMPS. Okay, so what is that? Count of ID, right? And then you have to use over. In over you're not using any order by plus. Okay, order by, you're just keeping is as it is. Now you can see here. So how many people are there total? So total of 6 employees are there. So that is why you're getting it, right? So similarly, you can also return one more dot with column of, what is that? Minimum salary. Okay, so minimum salary, minimum of salary. You can define anything you want. Okay, in over you're going to define window dot order by nothing. You can see here, what is the minimum salary? I think it's 55,000. You can see here, you're getting minimum salary, right? So this is how you're going to implement all, like all aggregate function will start working as window function by adding the over classing. You can see here, even if you want to find with column of max salary. Okay, so what is that? Max of salary. So you have to add over class. You have to define the window, right? So window, you can also define before also, no problem. Order by of, you can see here. You'll be getting 6 lakh or something, is that right? So this value is the maximum, that is 6 lakhs 70,000, right? So this is how. Okay, let's see here, I'm just using here show of 20 comma truncate equal to false. Okay, so if you use truncate equal to false, you'll be getting normal like this. Okay, here, okay, I think we are not getting properly. Okay, I hope you understood, right? So this is the maximum salary, right? So just I'm removing this one. You can see here, this is the maximum salary, that is 6,70,000. So this is how you are finding all aggregate function will start working. This is just a one use case, case one. So similarly, you can define with ID here. You can see here ID, I'm defining it. Here I'm going to define ID. This is the next use case, right? So in window, you're defining all these use cases. Okay, I'm just removing one, okay, so that we can easily look at it. Okay, so now you can see here order by ID. Now this is the second use case in the order of. You can see now you are getting, so 4,50,000, this is the one, right? So you can see here 4,50,000, and what is this value? So 2,50,000. Okay, this is the average values. Okay, this is the total running salaries. You can see here, so 4,50,000, 4 lakh, this is the addition. You can see final value, this one only, right? Final values, and this is the count. So in the order of IDs you're counting it. You can see here minimum salaries in the order of these people, like you're going from top to bottom, right? Like 1 to 6, and you are finding the minimum salary. Similarly, you can find it for max also. Okay, this is second use case. Similarly, you can also mention here each, right? So if I remove this one, okay, let's see final use case like partition by of whatever the column that you want. Okay, so partition by department dot order by. You can also, this is the final use case, right? I'm defining here for all over window dot, I'm defining it. Now this is the final use case, that is each department wise running totals you are finding, or running averages, running minimum, running count you are finding it. So what is this error? So there is a spelling mistake, right? Where is that? Partition, right? So spelling mistake. So still we are getting issue, right? So where is the issue? Window dot. Okay, spelling mistake here itself. Okay. So that is why always try to define first. Okay, so let's define it first now. So window dot, so we already defined now. Where is that? We already defined that. So this one, partition by department, right? So let's see here. I'm just using this one. Even if you want to use order by also, you can mention here order by of. I'm just using ID. Okay, so now if I execute this one, partition by department ID, both we are using, right? So you can also use directly also, no problem. So this is a little bit difficult, right? So if you want to write directly and all, so that is reason. Now you can see here, if I remove this one, you can define it directly. Okay, so now we'll be getting our data, that is each department wise running totals. You can see here. So in data analytics team, this is the one running totals, running averages and running count. You can see here. So in Bangalore 1 and 2, in data analytics team 1 and 2, in data science 1 and 2, in software 1 and 2. So likewise you can see in each department you are finding the running totals. So even if you want to find like different use case, like only, that is the final case, right? So you can also mention only this one. If I remove this one, now you can see if I execute this one, you are getting, now you will be getting for each, right? Because we changed that condition. So now if I execute this one, you will be getting for each department's total salaries, to averages, count and minimum salary for each department. You can see now, right? So this is how you can implement all window functions. This is just a how we are working aggregate function will working as window function, right? By adding just a overclass. But there are main window functions we have. Those are ranks, dense rank, roll number, lead and lag. Okay, let's see how we can do that. Now, so what is the data frame we have? Data underscore df, right? So I'll explain in brief, okay? Because if you understand these things, you can easily implement them. So this is how we have, right? So now, first what I have to do? So I have to define the order, right? So I want to return rankings from top to bottom. Like the highest one should be a 1 and the next one will be like followed by, okay? So now I'm just using order by salary descending order, okay? So how we can do that? So we already mentioned window, right? Window dot order by of, what is that? Salary. By default it's a ascending order, so you have to mention this is a descending order, okay? What is this order? So window specific object has new attribute descending order, huh? So for that you have, okay, inside that, so call of, you have to define like this, salary. For this one you have to define descending order, okay? Now we define, right? So then now we are going to implement in rankings, okay? So let's see here. First we'll see rank. So what is the rank? Rank is going to assign a value on the basis of any particular in any order, right? So you have to define the order here. So in previous cases, even if you're not defining order, no problem. But when you're finding the ranking functions or value functions, you have to define the order, okay? So now we are returning data underscore df dot with the column of, this is a rank. I'm just using RNK. Okay, so what is that? Ranking, right? So you have to rank, okay? Rank, you can see here it's not recommending. That means let's see, I'm going to importing them, okay? So from PySpark dot SQL dot functions, import rank is there, you can see dense rank is there, you can see, and row number is there, you can see lead is there and lag is there. So this is how you are going to implement, importing them, imported. Now you can see here it's going to recommend it. Rank, you can see recommended, right? So rank, I'm just finding, okay, this is just window function. After that what you have to do, you have to use overclass. In this overclass you already define the order. So in this order you are trying to assign in the ranks, you have to define it here, okay? And then you have to close this one and then let's see, show this one. You can see here, so it's returning like from the highest one to lowest one, it's assigned like rankings for on the basis of salaries in descending order. So if I remove this descending order, it's going to return, okay, let's copy this one. I'm just mentioning one more order here, not descending order, it's a ascending order now, right? By default it's ascending order, right? So now if I remove this one, you will be getting from lowest to highest. So lowest one will be assigned as 1. Okay, so these use cases will be like when you are finding the highest, top 1, top 2, right? So highest or lowest. So that is the way you are going to use these use cases, right? So let's see here, data underscore df dot with the column of, I'm just using ranking only, but here rank dot over, in this over I'm just using order by salary ascending order, this one, so that the lowest one will be assigned as 1. Now you can see 55,000 will be assigned as 1. You can see now 55,001, 76, 2. Likewise you can see here. So now if I filter like where rank equal to 1, you will be getting the lowest employee salary, lowest earning employee details. Right or wrong? So this is how you are going to see here. If I use where, okay, call of rnk equal to 1 dot show. Okay, what is your rnk is not defined now. So let's see here, I'm going to write another, because this is just extracted columns, right? So we should not write directly. Okay, this is the normal. Now I'm just assigning this as adf equal to this one. Okay, so now adf dot weight of call of rnk equal to 1. I'm just looking at it. So what is the error? So none object. Okay, I think we have mentioned show button now. So we should not use that show button. Okay, so if you are using show button, that's going to return like that. You can see now. So if I try to look at here, we will be getting the lowest ending employee details. You can see here, lowest ending employee details only, right? So this is how you can also define here, while you are finding the highest ending employee details also, you are going to refer with another data frame and then you can easily find it. Okay, now this is your returning rankings. Similarly, in place of rank, you are going to mention dense rank. Same thing. Okay, let's see that now. So what is the difference between rank and dense rank? In case of rank, if any like matches are there, the next one will be skipped. But in case of dense rank, it won't skip any sequence of number. It will be returning only sequence of numbers, no matter whether is there any number of matches are happen or not. Okay, let's see that now. So first we'll see data underscore df dot show. This is the data, right? So now at a time we are going to implement dense rank. Okay, first we'll see dense rank. Data underscore df dot with column of drnk, comma. Now dense rank, you can see it's recommended dot over. So we already defined the order, right? So I'm just using order by id. Okay. So now, sorry, not order by id, right? So we have to use order by salary, right? So I'm just using order by salary descending order. Okay. Then you have to close this bracket and then let's see here. Show. You can see here, it's returning rankings on the basis of highest to lowest. Even if you want to return like in ascending order also, you can mention here. I think we defined it right before. You can see here. So now you will be getting from lowest to highest the same rankings. If in case there are matches are there, dense rank won't skip the ranking. It will be returning next rank only. Okay. So similarly, this is for the entire organization, right? So you can also use here. Okay, while you are defining, okay, we defined, right? So let's see here. We are defining now. So depth wise order by salary descending order. Okay, so now window dot, we are going to find partition by of department and then order by of salary. I'm just using normal. Okay, even if you want to use like this also you can mention. Okay, so if you want to define any order, you have to mention like this. Now what we are trying to find, each department wise we are finding the rankings. Okay, so let's see here, data underscore df dot with the column of depth wise rankings, right? So you have to keep them in a single quote. Depth wise rankings we are allocating. So now what is that here? So you can also use rank or range rank, no problem. Rank dot over, in this over you have to mention that one, right? So we already defined it, right? So now, so this is for ranking for each department wise. Okay, now you can see if I look at this one, you will be getting each department wise. You can see here, so each department wise we are getting rankings, right? So similarly you can also use dense rank also. You can see dense rank, you will be getting same. There is no difference if because of there is no matching is there, right? You can see here same thing, right? So similarly you can implement all use cases like rank, dense rank for all. Okay, for with for the entire organization, for any particular, I mean only location wise, I mean each for location wise also you can find it. Okay, this is how you can implement. Now we are going to implement all at a time. Okay, let's see here, data underscore df dot with the column of, I'm just using R and K. What is that? Rank over, I'm just using normal order, order by salary only, not department wise. Okay, that to descending order. Now even if you look at this one, you'll be getting data. You can see here rankings. Now I'm just trying to return all at a time, so that I'm just writing one more, use slash to return, I mean to write a code in the next line, dot with the column of drnk dense underscore rank dot over, in over I'm just defining order by salary descending order. Okay, let's see that now. You can see you are getting same because there is no matches are there. Okay, so then let's see next one, that is row number with column of Rn. I'm just using Rn because of that is row number. Okay, you have to use row number na, row number dot over, in over you have to mention order by salary descending order. Okay, you can see you'll be getting error because of there is a okay, full stop is there, right? Now you can see you'll be getting data. So rank will be no matter whether whatever the values, it will be returning a sequence of values until unless if you are getting all. So therefore you will be using partition by or something, then only you will be getting, right? So now you can see for each and everything is considering as one. You can see it's written like row number, right? So similarly you can also find lead and lag also, right? Let's see that also. So now, so in order to find lead and lag, what do you want to find? With column of, and up to now we are not using any row number or something, right? But when you are finding lead values, you have to mention lead of what do you want to find? So lead of, I'm just using age. That means the lead values will help us to find the next values, lag values will help us to find the previous values. So lead of age dot over, so in this over I'm just defining order by, okay, you have to define it because, okay, I'm just removing this one because we are defining this order na, so that's why it will confuse. Okay, if I write like this, I'm just writing one more. Okay, this is for all rank, range rank and row number. Now we'll implement another. Okay, but this time you can see here data underscore df dot with the column of lead. So what is that lead that you want to find? I'm just using age. You can also find it for any column, no problem. Dot over, in which order? I'm just finding the order of employee IDs. Okay, I'm just finding okay, you have to define window na, window dot order by of ID. Okay, now if I look at this one, you will be getting the next employee who joined to the current employee. You can see here, so this is the current employee. Next employee, who is that? Mahi age is 45, right? So you can also define this as next employee who joined next to the current employee. So next employee age, you can see here, you'll be getting, right? So why you are getting null here? Because of there is no other employee. So if you want to replace that, you can mention here. So if you want to, if there is no value, that is by default is 1, this is a 1 default, and then you are going to define 0. If there is no, you will be getting replaced by 0, and 1 is for default values. I mean this is for, if you are not defining anything, that means 1 next values you are finding it. So if you are using 2, you are finding the next, like not next, second next you are finding. You can see here, you will be getting 2 zeros now. You can see because of you're finding not next, second next you're finding. For Giri, who is second next? Sam age is 56, right? So this is how you're finding lead values. This is for how lead that you want to find. By default it's 1. If you want to replace with any default values, you have to mention this one, right? So this is for default value. So if there is no value, it's going to replace with this value. You can mention 18. You can see that value will be replaced. You can see here 18 is replaced now. So this is for lead. Similarly, you can also find it for lag also. Previous employee age. Let's see here, I'm just writing here itself. So slash, now with the column of previous employee age. Lag of, I'm just using age, right? Then you have to use, okay, so I'm writing here 1 and 18 also, default values. And after that, you have to mention dot over, in over, I'm just defining the order. Window dot order by of, what is that? ID. Okay, now if I execute this one, okay, there is a bracket missing now, so you have to close that bracket, right? Now you can see here, so you will be getting previous, okay, still we are getting issue, okay, because we are missing full stop right here. Now if I execute this one, we will be getting next employee age. You can see here. So Giri is the current employee. Who is next? Mahi. Mahi age is 45. You can see here. Who is before? There is no before. That's why it is written as default value 18. So if I remove this one, you will be getting null values. You can see null value because there is no employee before. And for Mahi, who is before Giri? Giri age is 34. You can see here. For the last one, Yogendra, who is before, that is he. Like Ravesh, that Ravesh age is 42. You can see here. For Ravesh, Hari's age is 67. Right. So this is how you can also find lead and lags. So remember, this is for entire organization. So if you want to define for each department also, you can define in window here partition by of department, or you can also mention any location wise, or you can also mention multiple columns also. Okay. So here also you can define. Okay. So now you can see if I execute this one. But if you observe why you are getting null values multiple, because of in each department there is no before. So this is the first one who joined in this department. There is no one before. So that's why you're getting null value. Here also you're getting null values. You can see here. Right. So for the Sam, who is next? There is no next because in this department there is no next. Right. Now, so you can see here. That is reason you are getting 18. 18 means we use default value. If you mention here, if I remove that one also here, you will be getting null values. You can see here. So these are previous nulls, these are next values nulls because this is the last one in that particular department, right? So with this, we completed all aggregate function. I hope you understood like how we are implementing each and every aggregate function. Okay, I hope you understood. Thank you.